Linear algebra. Let's be honest, for a lot of us in machine learning, that term alone can be, well, a little intimidating. But what if I told you that the secret to really getting it isn't about memorizing a bunch of formulas? What if it's about grasping one simple idea? Organization. Let's try to look at this in a whole new way, together. So, when you hear linear algebra, does your mind immediately jump to a scene like this? You know, a massive chalkboard just covered in symbols and equations that look like they'd take a PhD to solve? Yeah, you are not alone. Linear algebra definitely has a reputation for being complicated and, frankly, a bit scary. But here's the secret. We're going to take all that crazy-looking stuff on the left and see it for what it really is in the world of machine learning. Just a simple, organized list of numbers. That's it. That's the big idea we're going to unpack today. We're flipping the script from intimidating to intuitive. Okay, let's dive into our first big idea here. For what we're doing, I want you to think of linear algebra less like a math class and more like a really good system for organizing information. The goal here isn't to start crunching numbers. It's to build a gut feeling for how it works. This right here is the fundamental truth. Just for a minute, forget all the formulas. Think of linear algebra as a powerful filing system for data. It's how machines take all the messy, real-world information and put it into a nice, neat structure that they can actually understand and work with. So let's start with the most basic building block of that filing system. How do we represent just a single piece of data? Well, this is where the idea of a vector comes into play. And that's all it is, seriously. A vector is just an ordered list of numbers, kind of like a single row in a spreadsheet. Each number in that list describes one specific thing, what we call a feature, about one single object. Let's make that a little more real with an example. Okay, so take a look at student A. We can describe this person with a few key features, right? Their height, their weight, and how many hours they study. That little list of numbers, 175, 70, 12, that is a vector. It's like a numerical fingerprint for student A. And this quote, it really gets to the heart of everything. A machine learning model doesn't see a student or a picture the way you and I do. It just sees a list of numbers. That's it. Vectors are basically the universal translator that turns our complicated world into the only language a computer really gets, raw data. All right, so a vector represents one student. But what happens when we want to look at the entire class? Well, that's when we need to scale things up a bit. And this brings us to the matrix. It's so simple. If a vector is a single row of data, then a matrix is the whole spreadsheet. You can just think of it as a bunch of those individual vectors all stacked up nice and neat to give you the complete picture, the whole data set. So remember our single vector for student A? And watch this. We just stack the vector for student B right under it, and then student C below that. See? Each student is a row, and each feature, height, weight, is a column. And just like that, we have our entire data set organized in this one clean, powerful structure. That is a matrix. So we have vectors for single things and matrices for whole data sets. But, so what? Why does this simple way of organizing things matter so much? What makes it so powerful for machine learning? Well, this structure is everything. It lets a model take unbelievably complex data and see it in a simple, orderly way. It's what allows computers to perform huge calculations super efficiently across millions of data points all at once. I mean, without this organization, large-scale machine learning it wouldn't even be possible. So here's how it usually works. The model gets an input, maybe the data for one new student. That's our vector. It then processes that against the patterns it learned from the entire data set, the matrix. And based on all that, it spits out a prediction. It's this really clean, efficient flow from a single point to the whole group and back to a new insight. And this isn't just some abstract idea from a textbook. This vector and matrix structure is the quiet engine running behind almost everything in modern AI. From the neural networks that recognize faces in your photos, to the recommendation systems that tell you what to watch next, to the huge language models out there, it's all built on this simple foundation. Okay, let's bring this all home. Getting this core idea isn't just about learning a new definition, it's about gaining a new kind of superpower for understanding how machine learning actually thinks. So if you walk away with just one thing today, please let it be this. For building machine learning intuition, linear algebra is not about the calculation. It is fundamentally 100% about the organization. So here's the simplest way to lock it in your brain. A vector, it describes one thing, one student, one house, one image. A matrix, it describes a whole collection of those things, the entire class, the whole neighborhood,
a full album of photos. Simple as that.
And you know what the best part is? At this stage, you don't even need to do the math yourself. The programming tools we use, things like TensorFlow and PyTorch, they are built to do all the heavy lifting for you. Your job is just to understand the structure so you can get the data organized in the right way. So now that you see how this big, scary topic really just boils down to a pretty simple, elegant structure, it kind of makes you wonder, doesn't it? What other intimidating concepts in technology are really just simple, core ideas hiding out in plain sight?